Good evening, everyone. This is Sarel van Grenen, aka Mr. VG, and I am excited to be in this journey with you. Today, we are going to have a look at three questions. Two of them sent in by Tsepang Boeni. Thank you. Thank you so much. You're a superstar. Emma, I did not forget about you. Ladies and gents, buckle up. We're going to have some fun today with calculus. The three questions that I chose is beautiful questions because they take a bit of a different view than you might have been used to. Different view from how you might know that the questions are usually structured. So enjoy it, and I hope that you are going to have a wonderful time with me today. Please remember, you are awesome.
For our first question, we are going to have a look at a question sent in by our now famous Mr. Tsepang Mboweni, who asked this question: find the point on the line y equal to 4 minus x that is closest to the point 7, 6. A small, very innocent looking question, but nonetheless quite a tricky one in this, because this question would easily be 7 or 8 marks in the exam. So before we do anything, I like to visualize what this actually means. In other words, let's start by drawing a line y equal to 4 minus x. So what I like to do is draw the scenario, got my Cartesian plane. The line y equal to 4 minus x is a slanted line like that. And then I've got the coordinate 7, 6. And I'm looking for the distance that is a minimum. For me to start this question, ladies and gents, we need to first of all find our monkey. Now our monkey is a coordinate or a set of coordinates. Now when I look at a set of coordinates, I don't even have a set of coordinates on that line. So what I'm going to do is very simple. I'm going to pick any random coordinates on that line. I'm going to make it x, y. The reason why I do this is so that I can maybe, just maybe, bring in my distance formula. Look, I know you might say, but sir, this is a paper 1 type question. What is the distance formula coming into this? Why do I have to know paper 2? I just want to warn you, this is a very important thing you need to know. That they may and they can ask you to use your paper 2 formulas in your paper 1. So remember, we can ask you analytical, Euclidean, trigonometry in paper 1 and also vice versa. In other words, we can ask you question 1 type or paper 1 type scenarios in paper 2. We are allowed to. And actually the GDE and the IEB have recently started, cross-pollinating between the two papers. So please remember that. You need to be aware of this, guys, before your prelim starts. You can be asked both paper 1 in paper 2 and paper 2 in paper 1. So let's have a look at the distance, because they say it's the closest point. So I would like to go towards distance. Now the distance formula, you guys all know, you guys and ladies. Emma, thank you for bringing that under my attention, that it seems like I'm always talking to boys, but I am talking to both boys and girls. So for all of you out there, I'm bringing in my distance formula. So I'm saying x minus 7 squared plus y minus 6 squared, all in a square root. Now, to avoid distance, or to avoid that we get confused between d for distance and d for derivatives, I'm rather going to call this L. So in other words, L. And then I'm going to square on both sides to get rid of that square root, because that just makes life horrible. So I'm sitting here with x minus y squared and y minus 6 squared. But I am sitting with a difficult scenario at this moment of time. At this moment of time, ladies and gents, I'm sitting with both x's and y's in my formula. That is an issue. Only when you get to AP Maths are you able to derive when you've got x's and y's. And even there, we would like to try and avoid this as far as possible because it really makes life difficult. What can we then do? Well, remember, x comma y actually lies on the line y equal to 4x. In other words, y is actually equal to 4 minus x. So I can replace the y in my formula with 4 minus x. So let's do that. So L squared becomes x minus 7 squared plus 4 minus x minus 6 squared. Now I'm going to simplify this as far as possible. So I am going to multiply out my brackets. But first of all, let's add in the back bracket. Let's multiply out my brackets. And I'm sitting with x squared minus 14x plus 49 plus 4 plus 4x plus x squared. And then if I add the like terms, I actually have an expression for L squared. Now, what is next? Remember, they're asking you for the closest point. So I know I've got to have that at a minimum. Now, how do I determine maximums or minimums? Well, plain and simple, ladies and gents, we need to derive that. We need to derive that and put it equal to naught. So let me go over to a new slide and let's try that. So from this slide, we have L squared equal to 2x squared minus 10x plus 53. For me to derive this, well, I'm going to go dl squared over dx equal to naught because I want it at a minimum. So if I derive that, I get 4x minus 10, putting it equal to naught. If I solve this, I get x equal to 2, 5. So this means at the point 2, 5, where x is 2, 5, the point on the line y equal 4x, it's closest to that coordinate 7, 6. But I've got to be careful. The question actually asks me, find the point. So I need both x and y, so I'm not done yet. So next up, I know it lies on the point y equal to 4 minus x. So let me substitute my x back. So 4 minus 2, 5 gives me a y value of 1, 5. So the point, the coordinates that are closest on that line to the point 7, 6 is the coordinates 2, 5, 1, 5. Now, one of my colleagues, who you'll meet in due time, actually showed me a completely different method of using this by using perpendicular lines and how the shortest distance between any 2 points is where the line from the one point is perpendicular to the other line. Let me throw out this challenge and ask you, go and try and see by using analytical geometry whether you can determine this without using any calculus. I'm going to throw that out there. Go for it. Question 2, ladies and gents, is an absolutely interesting question that I can say I found thanks to Cornwall Yale College. Now, this question is not so much a difficult question, but it is a really, really weird question. So this is the different way that they could ask you to derive. So the question says, given fx as being that really interesting expression, and f accent x being x squared minus 3 over x squared for all values of x may not be equal to 0. Just hit the pause button. We like to just scroll over that. But the reason why they simply say that x can't be 0 is, well, you don't divide by 0. We don't want to divide by 0, therefore we just have to specify it. It might not have any consequence for the actual sum. But what it does is that it just makes it more mathematically sound. So the question now is determine the values of A and C in the original fx. This is really weirdly asked, but I love it. So let's attempt it. So let's have a look at what they are actually expecting us to do. They're asking us of fx to find f accent x, because that is the information that was given to us. In other words, they're actually asking me to derive fx, and then we are going to look at comparing the f accent x we get from the one formula to the f accent x that was given to us. So I would like to derive fx. Can I derive fx? The simple answer is no. Why not? Because there's that x in the denominator. So to divide that x away is going to be our first step. So I'm going to split up that expression and put each of the numerator's expressions or terms over x, which means fx is actually equal to ax plus 5 plus cx to the negative 1. Now, please do not be afraid that you've got an a and a c value that are also some kind of constants. It's not the end of the world, but we can still derive in terms of x. So, f accent x is actually a minus cx to the negative 2. Remember that 5 simply falls away because the derivative of a constant is always 0. How does this compare to the f accent x that was given to us? It doesn't seem like there's much comparison. So let's simplify f accent x and see maybe something pops up. So I'm going to take every one of those expressions at the top in the numerator, divide them by the x squared. So I've got x squared over x squared minus 3 over x squared. Dividing those away gives me 1 minus 3x to the negative 2. Well, how do these two expressions of derivatives compare? Well, let's have a look. The green one is the one we found from the original fx. The blue one was the one that we got from what was given to us. Well, that's awesome because the a value is 1. And if I compare the coefficient of the x to the negative 2, then c must be 3. But there I've answered my question. Oh, this is awesome. This is really, really awesome. As a teacher, as an examiner, this gives me some awesome ideas to do for future reference. Ladies and gents, you might not have ever seen this in your life, but it doesn't mean it will not come up in your exams. So please be careful of just falling into a rut of, we've always just been asked y and find dy over dx, and it will always be asked that way. You've got to be able to put that sometimes out of your mind and go, but how can they ask it in a weird way? That's why I love these kind of questions, and I would love you to send us more questions like these on all the different topics we are going to handle. And I would love to share with you my thoughts on how to approach this. Now, the B part of this question was also a lovely, lovely question. The B part of this question looked like this. Use the information provided to draw a neat sketch of the function fx equal to ax to the 3 plus bx squared plus cx plus d on the axis provided in your answer booklet. We don't have one. That's okay. We'll just draw our own set of axes. Clearly indicate the coordinates of any intercepts with the axes as well as the turning point. The reason why I'm choosing this specific question as well is not that you would not have seen a similar one, but this one has got an interesting sting in the tail. But let's go and analyze what we've got before we actually attempt to draw it. So first of all, what we've got is that f of naught is 2, which means that is a y-intercept. Secondly, they tell me that f of negative 4 is 0. That means that's an x-intercept because y is 0. The third line, f accent of negative 2 and f of 1 is 0, or f accent of 1 is 0, my apologies. Where on a graph do we have derivatives equal to naught? Well, that must be at the stationary points. So in other words, we have this. Then we hit that interesting sting in the tail. And I'm going to just hit the pause button on trying to analyze further. And I'm just first going to draw what I've got. So first of all, I'm going to draw my set of axes and put in the y-intercept and the x-intercept because they are simple. And here's a beautiful thing that you should never forget. If you just draw those 2 points, you would have already have 2 marks out of the 6. As simple as that. Now, the stationary points, I don't know exactly the y values yet. So I'm going to just go and say, well, at negative 2 and at 1, somewhere on those x coordinates or those x values, I know that the graph is either going to turn or be stationary. But now I need to look at those last 2 bullet points. So first of all, it tells me fx or f of x smaller or equal to 5. That gives me the y values are smaller or equal to 5 where x is smaller than naught. In other words, if I draw this kind of on the left-hand side of 0, it creates kind of a barrier for myself that my function values never go above 5, but they can equal 5 there as long as x is then smaller than naught. And the same happens on the right-hand side of naught. They tell me that f of x is larger or equal to 1. So in other words, by 1, there's also a barrier, but now it creates a lower boundary. And it tells me that the y values can equal 1, where x is larger than naught. Here comes the thing. If they tell me that at negative 2, there's a stationary point, and I'm kind of guessing some minimum or maximum, and I look at the orange line there, it gives me the first turning point at negative 2,5 because they tell me that the y values can't be above 5, but it can equal 5. The same at 1. But at 1, the graph has a local minimum. So if I now connect the orange, the black, the red, and the other black, I get this kind of graph that forms f of x equal to that. Absolutely beautiful question. Beautiful because it's a bit weird, out of the ordinary. And that for me, especially if you're an IEB student, this is what you need to look out for. But I'm going to also warn the GDE students that more and more have we seen in the past 2 to 3 years that the examiners start looking at questions like this question 2, where they try and see, but how can we ask it a little bit different from the normal way of just deriving or just sketching graphs? Be careful of this. Do not fall into a trap of saying, it hasn't been asked before, therefore I'm not going to worry about it. The examiner can ask you anything. For our last question today, we are going to have a look at a lovely question again sent in by Tepang. Now, this question is a relatively straightforward question, meaning that I've seen it a lot of times, but I've also seen a lot of students struggling with this question. Not so much question 7.1 up to 7.4, but definitely 7.5. So if I look at question 7.5, the question asks, determine for which values of x is fx times by f accent x bigger than naught. When I look at question 7.5, that's the one I'm specifically going to have a look at. Then my question needs for us to actually use question 7.2's coordinates. So determine the coordinates of A and B. I just need those x values, which is at 1 and 17.3 or 17 over 3. My apologies. But when I look at this, remember how to determine those. They are turning points. In other words, they are where the first order derivative is equal to naught. And that's going to be where x is 1 and when x is at 17 over 3. So when I have a look at this question, I don't want to just go into, in my head, working with positives and negatives and where's increasing and decreasing. So what I'm going to rather try and do is I like to color code this. In other words, I'm going to make fx, my y values, in green, and f accent x, where the graph is increasing or decreasing, I'm going to try and make in blue. So I'm going to look at this question and I want to ask myself, where is something times by something else bigger than naught or positive? Well, I've got two options. First of all, I've got a plus times a plus. Secondly, I have a minus times by a minus. Now, I'm not going to worry about that at this moment of time. What I'm first of all going to just have a look at is go back to my graph, and let's start by going to the y values. Let's start by looking at the y values, where the y values are positive or where the y values are negative. So with the green ones, I'm going to start on the left-hand side of -1. Now, on the left-hand side of -1, the graph is positive. Then my graph dips below the y or the x-axis and it becomes negative all the way up to 4. After 4, it goes again above the x-axis, so my y values are positives until I hit 7. Then it dips below the x-axis again. So therefore, I've got negatives there. Now I've interpreted my y values. Next up, I'm going to have a look at my f accent x. Please be warned that I can even give you something you do not know how to derive, like trig functions or log functions, or even exponential functions that you have no clue how to derive, and expect you to work with f accent x. Please don't freak out, flip out, throw your computer across your study just by hearing this or sending me emails. But guys, it's simply that we are asking you to interpret the derivative, whether the graph is increasing or decreasing. Is the graph going up or down as I move from left to right over my interval or over my domain? If I look at this specific graph, the points that I have as being really important for derivatives is the points, the coordinates A and B. On the left of A, my graph is decreasing. So on the left of 1, my graph is sloping downwards. Between 1 and 17 over 3, my graph is sloping up. So my f accent x is positive. If I look on the right-hand side of 17 over 3, well, then my graph is going down. It's sloping downwards. So my derivative is negative. So be careful that you get stuck, but so I don't know how to derive it, or I don't have a formula. Guys, it's about the form of the graph, increasing or decreasing. Now we need to look, where do I have a minus times by a minus or a positive times by a positive at the same time? Let's look at our different domains. First of all, on the left-hand side of -1. On the left-hand side of -1, I've got a minus times by a plus. No, that doesn't work out. Between -1 and 1, I've got a minus times by a minus. Boom! That works out. Now what about between 1 and 4? There I've got a plus times by a minus. No, that doesn't work out. But what about between 4 and 17 over 3? There it works out. Between 17 over 3 and 7? No, that doesn't work out because I've got a minus times by a plus. And lastly, on the right-hand side of 7, it works out because I've got a minus times by a minus. So this means I've got 3 possibilities with this. First of all, x could be between -infinity and -1. The reason why I don't use square brackets is because they didn't say equal to 0. And in any case, infinity is never equal to infinity. Or the x is never equal to infinity. Excuse my slip of the tongue there. X cannot be infinity. Therefore, we've got a round bracket. By -1, it's also a round bracket because I don't say equal to 0. Next up, I've got between 4 and 17 over 3. There's my next one. Okay? I apologize. I just saw that my first one is completely wrong. My apologies. As I'm recording this, I'm saying, oh, I wrote down the wrong thing. The actual one is between 1 or -1 and 1. I'm so glad that I saw that. This is amazing. I love when you make a mistake and you can correct yourself in the same breath. Lastly, boys and girls, our last one is going to be from 7 to infinity. When I look at the again, infinity is never a square bracket. It's always a round bracket. A question like this could easily set you back 4, 5, or 6 marks. Maybe 3 marks. I don't know, depending on your examiner. But they love it. They absolutely love it. Ladies and gents, please remember, ask if you are struggling or ask your teacher if you are unsure. Please relook this video. Try it yourself if you are struggling to get the hang of this fx times by f accent x things. Practice, practice, and practice.
Whoa, what an awesome 3 questions. I love them. They are a bit different, a bit tricky, but I hope you enjoyed them, ladies and gentlemen. Please remember, subscribe. Hit that bell to notify you when there are new content coming up. Remember, this is a nice long journey that we are on. If you would like to send us some questions, please come. Feel free. And I would love to answer, and I'll send you a shout out. I'll mention you on YouTube, and who knows, you might become famous because of us. It would be my honor to make that happen. Remember, subscribe, hit that bell below so you get those notifications. I encourage you as well to go to the Junior Tukkie Winter School page on a regular basis, because I would love you to receive the new content fresh from the press. If you don't know where to go, or if you haven't been there yet, that's shocking. Just joking. Please look in the comment section. I will post a link there for you to go and subscribe. Have a wonderful rest of your day. I hope you enjoyed my beanie. I'm enjoying it because it is really cold tonight. So have a wonderful and blessed weekend and week ahead. Cheers.